Hello, sixth graders. This is the first video that I am going to produce for you to guide you toward multiplication and division with integers. Now, it's very easy to do, but I'm going to hold off on giving you the very simple rules for multiplying and dividing with integers or with any numbers where one or both might be negative. I'm going to hold off on the rule. It's very simple. Please don't be intimidated by multiplication and division. It's easier than adding and subtracting with integers. But I want to lay a foundation, and I want to get you to really buy into what the rules are going to end up being. Let's start by reviewing some things that we know, and then coming to one which is really going to be the key to going forward with multiplying and dividing integers. We're going to say that A can be any real number. For all real numbers, A. These first three you know. Very young children know them. It may not be presented to them this way, but you know what A plus 0 is. It's A. And you know what 0 times A is. It's 0. And you know what 1 times A is. In fact, when you're in first grade, you don't spend much time trying to memorize the addition facts with 0. 9 plus 0 is 9, and 5 plus 0 is 5. You don't have to memorize those individual ones. Even a very young student generalizes to the fact that a number plus 0 is the number. And similarly with multiplication, it's pretty easy to remember the 1 times table. 1 times any number is the number, so 1A is A. Now I'd like you to guess at what you think. Take a few seconds, pause if necessary. What do you think negative 1 times A is going to be? Did you say negative A? Did you think it might be negative A? That's it. An A with a minus sign in front of it. Now we know that that's also, I intentionally said negative A there, and that's not wrong to say that, but this also means the opposite of A. And this is going to be the foundation that we're going to build on to get to the rules for multiplying and dividing with negative numbers. Negative 1 times A is equivalent to the opposite of A. Now let's see why. I believe I've said to you many times that math is incremental. More than any other subject that we study, math builds upon what comes before. And even though we're now in the area of multiplication and division with integers, we're going to rely on something that we've already, I think it's safe to say, proven. We have shown that a number plus its opposite is 0. A plus the opposite of A is 0. I put this down at the bottom. It's really the foundation of this little proof. What we are trying to show in this proof is that negative 1 times A is the opposite of A. We're going to assume that this is true. We showed how it's true with vectors, right? A vector that points to the right and a vector that points to the left that are the same lengths. When we move the beginning point of one to the end point of the other, the result is at 0. Okay? You can't prove everything in math. You have to begin with certain things that are just sort of assumed. In this proof, we're going to assume that 1 times A is A. I put that on the previous board. Things we already know, things we learned in 3rd grade. I'm not sure it's possible to prove that 1 times a number is the number. I think it's something we just assume. I mean, it's logical. You know, multiplication is repeated addition, so 3 times 4 is 4 plus 4 plus 4. Well, 1 times 4 would be 1 4 or 4, so it makes sense. We're going to accept that 1 times A is A, and we're going to also accept that opposites add to 0, but I feel more confident about this one, believe it or not, because we've shown with the addition of vectors why this is true. Now look at what I wrote up here. I put a question mark above the equal sign. This is something that happens probably 99 times out of 100 or more. When we see an equal sign, it's just by itself. But we can have a not equal to sign. You're familiar with this. Remember this little sidelight here. This has got nothing to do with what we're doing right now, but you see we have the not equal to sign. 3 to the 2 power is not 6. And of course that logically is the not equal to sign. Well, sometimes in math you see the question mark above the equal sign. We're wondering, are the two things equal? And spoiler, we're going to show that these two are equal, that a plus -1 times a does in fact equal 0. We are going to show that. But the most important part of understanding this proof is that if this statement is true, then we have shown that -1a is the opposite of a. Make sure you understand that before we go any further. You have to look down at the bottom, right? A plus the opposite of a is 0. So if this is true, we've got a plus this thing here equaling 0. The only way that this statement can be true is if this thing here is the opposite of a. The only number you can add to a to get 0 is the opposite of a. Okay? It's going to take different people different lengths of time to see this, but it doesn't make any sense to go on with this video unless you understand how we're trying to accomplish this. We're assuming that this is true, and we've shown it. Okay? So if we look back up here, we have a plus something equaling 0. The only way that that can be true is if that second number is the opposite of a. So if we can prove this is true, we have proven that -1 times a is the opposite of a. So here we go. Now we have to change that is it equal to an equal sign. We have to get rid of that question mark. Here's the first thing we're going to do. I'm going to rewrite this with simply one little change. Still going to put the question mark because we haven't proven it yet. We're not done. But notice the slight change that I made. Instead of a, I wrote 1a. And as I said, I'm not going to prove that to you. I'm going to accept that to be true, that a is the same as 1a. Okay? Now, the distributive property is huge in math. You encounter it as early as 3rd grade. You learn how to do something like 6 times 42. 6 times 42 is 6 times 40 plus 6 times 2. 240 plus 12, 252. The distributive property is essential in 3rd grade, and it is essential in every level of math. And again, similar to 1a equaling a, it's something that we're just going to assume is true, a basic principle of math that we build the rest of the structure on. Sometimes when we need to do something, we need to think about the distributive property backwards. The distributive property backwards. Notice that in each of these things we're adding together, there is an a. We can do something that is often called in, starting now and going through with pre-algebra and algebra and high school math, a process we call factoring out. Factoring out a common factor from 2 different terms or 2 different things that are being added together. The key here is that there's an a here and there's an a here. Watch what I can do. 1 plus -1 in parentheses times a. And again, we still have that question mark over the equal sign. We're trying to prove that this statement is true. And if we prove that this statement is true, we have proven that -1 times a is the same as the opposite of a, down here. Okay? What did I just do? I took the a that was in each of those terms, and I did something that we frequently call factor it out. Now that phrase factor out makes perfect sense because I've represented the sum of these 2 things as the product, and that's why we can call it factor. Factor has to do with multiplication. It's 1 plus -1 in parentheses times a. So that's why it's called factoring. We have actually represented this sum of two numbers as the product of two numbers with the two factors. And the A is outside of a parentheses. That's why it's called factor out. If that's confusing, think of it this way. It's the distributive property backwards. If I gave you this, you could apply the distributive property and say, okay, I'll do 1 times A, or A times 1 to get 1A, and I'll do A times -1 to get -1A, and the plus sign in between. Just like you would do with 6 times 42 as 6 times 40 plus 2, right? You got 40 plus 2 in parentheses times 6. You would do 6 times 40 plus 6 times 2 to get the 252. All right? This is the same thing. A times 1 is 1A plus -1 times A, which is -1A. We have factored out the A. Look at that parentheses. We're trying to prove something that's true about multiplication, but we're using addition. Anything we learn in math is at our disposal in the future to prove something else, to build a structure little by little from a few basic assumptions. When you add two opposites, you get 0. 1 plus -1 is 0. So I can now replace that parentheses with 0, and we have 0 times A is 0 with a question mark. Well, I can now remove that question mark because here's another of those things I can't prove to you, but we assume to be true. One of those basic assumptions about math: 0 times a number is 0. So we have shown that this first statement up here, I've now removed the question marks, we have shown that this is true. A plus -1 times A is 0. So, keeping in mind that the only thing you can add to A to get 0 is the opposite of A, this -A here, the opposite of A, must be the same as the -1A that I put up here to begin with. Okay? This opposite of A from down here, which we knew, has to be the same as that. We have proven something that some of you might have thought was obvious. Well, yeah, -1 times A is -A. -1 times A is the opposite of A. But you can be absolutely confident going forward that it is in fact true. This is a proof. This is what math is all about. So from now on, we can always assume that -1 times a number is the opposite of that number. Bye-bye for now.